Alright, welcome to my video. This is Mrs. Clark. We're going to be talking about how do we use slope to classify pairs of lines. So how do I tell what type of lines these are using their slope? So it's probably been a while since you've done slope. Here's the slope formula to remind you. Slope is rise over run. We can count it from a graph using this. If you're just given the points, you can calculate it using this by subtracting the y's over subtracting the x's. Slope is usually a fraction, although sometimes it does reduce down just to a whole number. So if you have a positive slope, you're usually going up as you go left to right. You're rising and running and rising and running and rising and running, and that would make it a positive slope. If you're having a negative slope, you're going down, so your rise is down, and then you're running to the right, and then rises down, and then you're running to the right. So it's really a fall and a run and a fall and a run, but that's what a negative slope looks like. We always read our graphs left to right, so two different types of slope depending on whether you're going up or whether you're going down as you go left to right. So those are there just to remind you about slope. We're going to actually use it on the inside here. So if you look at this first example, it says graph points A and B, then draw AB. There is a line symbol over this. It's very faint though, just so you know it is a line symbol. Graph points C and D, and then draw CD. So I have two lines that I'm going to be graphing based on graphing these points. So first we're going to graph these points and label them and connect them. Then we'll graph these points, label them, and connect them. So let me do that now. So if I want to graph A, I have to graph it at -5, -2. So let's remember the first is our x and the second is our y. So this is my first point. So if I was using that formula, this would be x1 and y1. So I'm going to go to the left because the x is negative. So from the origin, I'm going to start. I'm going to go to the left 5, 1, 2, 3, 4, 5. And then I'm going to wait, and my y is a -2, so I have to go down 2. So 1, 2, and then I'm going to make my dot, my point right here. So this is -5 down 2. So then that's just going to help me plot it. So then I've got an A, and then we put an A on that. All right, next I'm going to graph my B, which is 3, 6. So that's my x2 and my y2. Second point, that's what the 2's stand for. I'm going to start at the origin again. I'm going to go to the right this time because it's a +3. And then I'm going to go up because it's a +6. And then I'm going to make a point there, and that's going to be my B. So I've got 2 points. I'm going to then grab my ruler. Alright, so I'm going to connect these 2 points. I'm going to draw a line with arrows. I said with arrows just to remind you that a line does go on forever. It's going to go through these 2 specific points, A and B. And I'm going to look at the slope of this point. I'm going to go from A to B. I'm going to count how much the rise is and then how much the run is. So if I rise from left to right, and then I run until I hit the B. So I'm going to count how many boxes it is that I rose. So it's 1, 2, 3, 4, 5, 6, 7, 8 boxes is my rise, and then 1, 2, 3, 4, 5, 6, 7, 8 boxes is my run. So my slope, which we use M, I'm going to put a little AB down below it, so I know it's the slope of AB, is my rise over my run. So my rise was 8 and my run was 8, so it's 8 over 8. Which simplifies down to 1 over 1, which is just 1. Okay. Alright, then I'm going to find the slope of my next line, which I'm going to write, just get it ready down here, is the slope of CD. So I got to actually graph them. So C is 2, -7, so I'm going to go to the right 2 and then down 7 and make a C. And then D is 8, -1, so you're right here. And then I'm going to connect these and make a line. So the purpose of our note page here is we're going to compare or classify these pair of lines. We want to know what's true about these 2 lines. We're going to use slope to do that. So if I count my rise and run from here, I already used orange. My rise up until I'm level with the D, and then over to the point D, and I'm going to count how many I rise and how many I run. So I rise 1, 2, 3, 4, 5, 6, and I run 1, 2, 3, 4, 5, 6. So again, my rise and run are the same thing, so 6 over 6, which reduces again to 1 over 1, which is just 1. So if we notice, I got the same answer when I reduced it for both slopes. So what kind of lines are these? Well, what do they look? They look like they're parallel. I'm going to tell you that they are parallel lines, so let's write that over here. We know that they're parallel because we just checked their slope. And when we have parallel lines, their slope is the same. So I'm going to write that down here. Parallel lines have the same slope. So when you check the slopes of two lines, if they are in fact parallel, they will have exactly the same slope after you have simplified them. All right, so when we're going to look at the second example, take a look at what kind of lines we have there, take a look at their slopes. All right, so now we're going to be graphing W at negative 9, 4, and X at 5, 8, I'm going to connect them to make a line again. Alright. Then I've got to graph Y at negative 8, 7. It's going to be up here. It's kind of close to my other one. And then Z at negative 6, 0. 1, 2, 3, 4, 5, 6. 0 is going to stay right down here. I'm going to connect those. Make a line. These are definitely not parallel. I know that because they are intersecting. So I would assume, based on what we just found out, they don't have the same slope. Because they're definitely intersecting, which means they can't be parallel. And if you look, one is going up and one is going down. So one has a positive slope and one has a negative slope. So let's actually figure out what their slopes are. So first I'm going to start by finding the slope of WX. So the slope of WX, I'm going to look for my rise and my run. Do it like I just did on the last one. I'm going to go from W to X. I'm going to rise until I'm in line with with X. And then I'm going to run until I hit the X, and then I'm going to count up how many I moved. I'm going from point to point. So I rise 1, 2, 3, 4 boxes, and I run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, I think I just counted that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, I missed one. Because I went all the way over to the point, not just till I hit the line. My line was a little off. So my rise was 4 and my run was 14. It's going up, so it's 4 over 14. So those are both even numbers, so if I reduce that, divide by 2 on the top and bottom, I get 2 over 7. So 2/7 is my slope for that one. So then I'm going to find the slope of my other line, which is YZ. So let me count the rise and run of that one. It's actually a fall this time, so Y, I'm going to start at Y and go down until I'm in line with Z, and then over. So how many did I go down? Well, I went down 1, 2, 3, 4, 5, 6, 7. I went over 2. So because I went down, it's negative. So negative 7. Falling down is bad. Negative 7 over 2. And if you notice, this is an odd number, that's an even number. I can't divide them by 2. 7's also prime. There's nothing else that goes into 7 other than 7, so I can't reduce that anymore. But there is a pattern that you can see. One is 2/7, the other one is -7/2. We said one is positive because it's going up, and one is negative, it's going down. But their numbers also have a pattern. This is 2/7. This has a 7 on the top, a -7, and a 2 on the bottom. So they're the fractions are kind of flipped. So we call that reciprocals. So these lines, not parallel, are actually perpendicular. So we're going to say perpendicular lines have opposite, meaning one is positive and one is negative. That's the math word for opposite, or that's the meaning of the word opposite in math. And in parentheses, I'm going to put a plus and a minus, plus/minus, so we remember that's one positive, one negative. Reciprocal and I'm going to just draw a fraction, a over b, and I'm going to put like this little double arrow to show that it's like flipped over, so we remember that's what a reciprocal means. Slopes. So they have opposite reciprocal slopes. So when you see this pattern where the numbers are the same but one's the numerator and one's the denominator and then they're flipped and one's whole slope is positive and the other whole slope is negative, that tells you that you have perpendicular lines. So let's add that in on the side here. Perpendicular lines. So that's the relationship between perpendicular and parallel lines. If you have things that are neither one, you're not going to see either of these things happening. So there'll be no pattern with opposite reciprocals, or they won't have the same slope either, and then they're just going to be intersecting lines. So nothing special happens with intersecting lines. Alright, so fold this up, and then you're going to go ahead and glue this in your notebook. Check the daily agenda to see the page that it's supposed to go on, and then thank you for watching. Let me know if you have any questions.